Hello and welcome to my metal shaping tips and tricks videos. In this video, I'm going to show you how to bend a right angled flange with a very tight inside and outside radius. First, you need to make a cardboard template. Then from your cardboard template, you can make yourself a template from 1/2 inch thick plywood, as seen here. Remember, when you are making your template, you will be forming your material around the outside of the template. Therefore, the template will need to be the material thickness smaller all round. Then place the template on the material you wish to use. In this case, it's a 1.2mm galvanized steel, 25mm in from the edge, or 1 inch if you live on the other side of the big pond. And mark around it, as seen here. This method of marking around it with the washer I first saw on Trev's blog, which just goes to show, even at my age, you're never too old to learn. Now you will need to make 2 plywood templates, one of which will need to be accurately cut out. The other one is just for a backing plate to assist with clamping the metal down, which does not need to be as accurate. So I advise that you mark the accurate template so you will know it's the one to form your material around. As this repair panel is for the left-hand side of the car, I will be bending the flanges up as pointed out here. If this panel was for the right-hand side of the car, I would have to bend these flanges down to get the opposite hand. Next, sandwich your material between the 2 wooden templates on the datum line as seen here. This will hold it all together on the datum line while I clamp it down very tightly to a bench, as I normally would do. But on this occasion, I haven't got a bench free, so I'm going to do it in the vise. Now you must clamp this very tightly. Mole grips will not do. Use proper G-clamps. I've got it clamped very tightly in the middle of the vise and use proper G-clamps either end. And I'll just put 1 pair of mole grips in the middle by the vise for now, as I've got 2 G-clamps. Now this will take a little more hammering than usual because I haven't been able to clamp it down onto a solid bench. As it's not a very long repair panel, the vise should be sufficient. Having hammered over the first half, I will now move the mole grips from the middle to the outside and put the clamp in the middle where it's most needed at the moment. The end where I've just hammered over accurately on the bend line will not move now, so it's okay to use the mole grips this end and move the clamp to the middle by the vise. For this inside radius, you can see I'm using the ball of the hammer, and for the outside radius, I'll turn the hammer around and use the flat side. You must use the ball end of the hammer for the inside radius, moving backwards and forwards along the length of the radius. Don't try and hammer over one area all at once, as this will cause the metal to pucker up in places, which will then make the job much more difficult. The outside radius will take a lot more hammering because this is a very tight radius, and the metal needs to be shrunk a lot. So you just have to persevere with it and keep moving backwards and forwards till you eventually finish. I know some of you may be thinking, why doesn't he just do it on a bead roller? Well, the answer to that is most of the bead rollers you can buy these days are not much better than a kid's toy, and are not really capable of doing this on a 1.2mm thick material. Even though it says on the box they will go up to 1.2 millimeters. It's simply not true. When you see people on YouTube doing demos on these bead rollers, they are only using aluminium or 0.8 millimeter thick steel. To me, they're just not worth the money. If I were to buy one, I would have to buy a real one, which would cost thousands. And for the amount of times I would use it, it's just not cost effective. On this outside radius, you can see there are a few small puckers. This is because the metal has shrunk so much in one direction, the excess metal has moved out in another direction and made the flange wider at this point. And I cannot hammer out these puckers on the wooden template because that metal is now overhanging the wood. So I'll show you how to get rid of these small puckers. This outside radius just happens to be 16 millimeters, which is 5/8 of an inch. I found this piece of 1-inch nominal bore pipe, which just happens to have a 5/8 inch outside radius. Wasn't that lucky? I can hammer out these small puckers over this piece of pipe, as seen here. As I said earlier, on the outside radius there was a lot of shrinking going on, and metal has to go somewhere. So what has happened is the metal has actually become thicker at this point and moved outwards to overhang the wood and made the flange wider at this point. So all I need to do now is grind off the excess material. On the inside radius, the metal has stretched, therefore making it thinner. As some of you may have noticed, it has become so thin in one area, it caused the metal to split. But this won't matter, as I will put a weld over this split, and no one will ever see that going down the motorway at 90 miles an hour. Now that concludes this half of the video. If you wish to see how to fit this repair panel, I will show you in the rest of this video. Now this is where I intend to fit the repair panel you've just seen me making. As you can see, after blasting, this area is very crowded and needs replacing. It will fit down here after removing the old panel and will be welded to the rear wing as it was in the factory. That way, it doesn't look as though it had a repair done, and it will still look as original as the day it left the factory. The best way to remove this old panel would be to split along this seam here, then split along the length of the panel and the other end. As I've already drilled through the spot welds underneath this panel, it will now pull off quite easily by just bending it back and forth till it snaps off. On the inside, I prefer not to drill through the spot weld because I would have to repair all the holes. So the best way to remove the old panel here would be to cut through the spot welds with a grinder just halfway through the material and then bend it back and forwards till it snaps off. Then you can grind flush the remainder of the spot welds as seen here. In the corner there are a few more welds which I cannot get the grinder to, so I have to use the windy gun. Just a bit of grinding to do here. This small area I'll do a bit later. Now I need to drill some more holes here for plug welds. Underneath will be plug welded through the holes in the floor, which I drilled to remove the old panel. Here you can see where I punched some holes in to plug weld this repair panel in position. Now I've got it clamped and tacked. I need to put a couple of screws in here and here to pull it up tight and then plug weld it all up. Now this row of welds here, I will need to have a high setting on my welding set because at this point it's being welded to the reinforcing bracket in the boot, which is made from a much thicker material. I'd like to thank you all for watching, commenting and subscribing, and I hope you've enjoyed watching this video. And if you like it, please give it a thumbs up.